In this chapter, we shall look at some of the features of CL programming. Let us begin with command prompting. You have seen how we can prompt for the parameters of a command from the command line using the F4 function key. We can also prompt a user for the parameters of a command in a CL program at execution time. We do this by preceding the command in our CL program with a question mark. When we execute our program, we will automatically be prompted for the parameters. Alternatively, we can also have the program supply some of the parameters and prompt the user for only some parameters. Let us see how this can be done. For example, consider the display object description command. Suppose we want the output to always be sent to a spool file. We can supply the value in our program itself, in which case the user will not be allowed to change it. To prompt the user for a particular parameter, we can precede the parameter with two question marks. This causes the default value of the parameter to be displayed on the screen, while also allowing the user to change the value. We can also precede a parameter with two question marks and include a value for the parameter. In this case, the value pgmtest will be displayed to the user, which he can change. If we precede the parameter with a question mark and an asterisk, the field will become protected. Here the default value will be displayed and the user will not be allowed to modify it. Similarly, if we use a question mark and an asterisk and also include a value for the parameter, the value will be displayed and the user will not be allowed to modify it. The question mark and a minus sign can be used to hide a particular field on the display. Here also we can specify a value for the parameter, in which case that value will be used, otherwise the default value will be used. This table summarizes the selective command prompting options. Let us move on to the next topic. Here we shall see how external attributes can be retrieved and used in a CL program, and also see how these values can be changed from a CL program. To work with job attributes, you have the commands retrieve job attributes and change job attributes. Similarly, you have the retrieve system values and change system values commands to work with system values, the retrieve user profile and change user profile commands to work with user profiles, etc. Let us look at the retrieve job attributes command by pressing the F4 key. Here we have a list of attributes such as the job name, username, job number, output queue, type of job, that is batch or interactive, user portion of the jobs library list, the jobs current library. For each of the variables that we want to retrieve into the program, we specify a CL variable into which the value can be retrieved. The retrieve job attributes command is valid only within a CL program and cannot be executed from the AS400 command line. To change an attribute of a job, we can use the change job command. The change job command is normally used in conjunction with the retrieve job attributes command. You would use the retrieve job attributes command to retrieve the job attributes and save the values of the attributes you need to change so that the original values can be restored later on. Let us look at a sample program. You use retrieve job attributes command to retrieve the name of the job into a CL variable jobnm and name of the output queue into another variable jobq. We then use the change job command to change the job's output queue to the one required for running the accounts application. We then call the accounts application. When the application completes, we use the change job command to change the job's output queue back to the original output queue, which we have saved in the variable jobq. Let us look at system values. System values on the AS400 are a set of attributes that are common to the entire system. They are not objects and cannot be created or deleted from the system. To bring system values into our program, we can use the retrieve system value command. On the return variable parameter, we specify the CL variable into which this value is to be stored. Let us look at an example. Some of the most commonly used system values are the ones that contain the system date and time, such as queue date and queue time. Here we use the retrieve system value command to retrieve the current date from the system value queue date and store it in the CL variable cdate. Similarly, we retrieve the current time from the CL variable queueTime into the return variable cTime. We can now use these values in our program as we have done in the send break message command. We can also change system values using the change system value command. For example, say we want to change the date separator to colon. On the value parameter, we specify the new value. The convert date command is a very useful command that can be used in CL programs for working with dates. This command is used to convert a particular date from one format to another without changing its value. Let us look at the parameters of the convert date command. On the date parameter, we specify the date which we want to convert. This can be a constant value or it could also be a CL variable. The toVariable parameter is used to identify the CL variable that will hold the converted value of the date. The from format parameter is used to specify the format of the original date. This parameter can have a value such as star job, star system value, star month day year, star year month day, star day month year, star Julian, etc. On the toFormat parameter, we specify the format to which we want the date to be converted. The toSeparator parameter is used to specify the date separator that is to be used in the new format. Here we can specify a character such as slash, hyphen, period or comma. We can also specify that the value is to be taken from the job description or system value, or that no separator character is to be used. If star none is specified, there will be no separators between the month, day and year. Let us take a look at an example. A sales maintenance program saves each day's sales information to a new member in the sales file. Before the application is run, we have to add a new member to the file. The new member has to have a name which is a combination of the string sale followed by the Julian date for that day. We can have a CL program that will retrieve the current date from the system value QDate and store it to a variable CDate using the retrieve system value command. The convert date command is used to convert the date into the Julian format with no separators. The result is stored in the variable JDate. We now use the add physical file member command to add a new member to the file. On the member parameter, we specify the member name as sale concatenated with the value of the variable JDate. Now we can call the application program. The next topic that we shall look at is data areas. A data area is an AS400 object that is used to hold data that is to be shared among jobs on the system. A data area can hold only a single piece of data. In the case of character values, it could be logically split into multiple pieces of information. The create data area command is used to create a data area. On the data area parameter, we specify a name for the data area. We also specify the library in which it is to be created. On the type parameter, we specify whether the data area is to contain character, decimal or logical data. The length parameter is used to define the size of the data area. The maximum length of character type data area is 2000 characters. Data areas which hold numeric data can be up to a maximum of 15 digits, of which 9 digits can be used for the decimal portion. Logical data areas have a fixed length of 1. On the value parameter, we can specify an initial value for the data area. The text parameter is used for providing a descriptive text. Let us look at some examples. Here we use the create data area command to create a character data area CNAME which has a length of 20 characters and an initial with value of bitmappers education. On the text parameter, let us specify customer name. Here we have a decimal data area 9 digits long with 2 decimal positions, an initial value of 1234567.89 and descriptive text amount. The display data area command can be used to view the contents of a data area. On the data area parameter, we specify the name of the data area. On the output parameter, we use either an asterisk to specify that the data area is to be displayed on the screen, or star print to specify that the contents of the data area are to be sent to a spool file. The output format parameter is used to specify whether the data should appear either in a character or hexadecimal format. For example, here we use the DisplayDataArea command to display the data area bill AMT on the screen. Pressing the Enter key will display the data area. The RTVSYSVAL command is used to retrieve the contents of a data area into a CL program. On the data area parameter, we specify the name of the data area. On the return variable parameter, we specify the CL variable into which the data is to be read. For example, here we are reading the contents of a data area invoice number into a CL variable INVNUM. In the case of character data areas, we can extract a portion of the data area. Say we have a data area that contains all the months of the year. Supposing we want to use March in our program, we can use the RTVSYSVAL command. On the data area parameter, we specify the name of the data area, that is months, the starting position from which to retrieve the characters, and the number of characters to be retrieved. On the return variable parameter, we specify a CL variable, month, into which the value is to be placed. The CHGDTAARA command is used to modify or change the data area. Here we have a value parameter that is used to hold the data that has to be written to the data area. The data area parameter contains the name of the data area. As in the case of the RTVSYSVAL command, for character data areas, we can write to a portion of the data area by specifying the starting position and the number of characters to write. We also have the delete data area command that is used to delete a data area. Next, we move on to the local data area. This is a special type of data area that is automatically created by the OS 400 whenever a new job is started. The local data area is associated with a particular job and is deleted by the OS 400 as soon as the job ends. The local data area is used to pass information between the different programs running in the same job and is not visible to other jobs. Also, they are not associated with any particular library, nor can they be created or deleted by a user. The local data area has a fixed length of 1024 bytes and can only contain character data. The retrieve data area, change data area, and display data area commands that are used with the general data areas are also used to work with the local data area. On the data area parameter, we specify *LDA to indicate that it is the local data area. Summary. In this chapter, we saw a number of programming features that can be used to write CL programs. We saw how we can prompt the user for command parameters at execution time. We also saw how various job attributes as well as system values could be retrieved into a CL program and used within the program. We also saw how the job attributes as well as system values could be changed from within our CL program. We saw the ConvertDate command and how it can be used effectively in our programs. And finally, we saw how to create and use data areas. We also saw how to use the local data area.